They say that most eras end, but such is not the case for a unique group of people who build and launch a pioneering American launch vehicle whose satellites revolutionized weather forecasting, brought live television events from around the world into your home, and investigated the mysteries of our universe. During the early years of America's space program, most of the public's interest was focused on man going to the moon. But during that same incredible epic, a story unfolded about a little publicized launch vehicle named Delta, which orbited history-making satellites that helped to change the culture of hundreds of millions of people living on our planet. Today, Delta has a vital date with destiny. It is about to launch a scientific messenger to keep an appointment with the beginning of time, the creation of the universe. This is the story about Delta and its people in their pursuit of excellence with a legendary rocket which earned the reputation of being the best in the world. Today marks the 189th Delta launching over a 30-year period. This magnificent flying machine will send the Cosmic Background Explorer, or COBE for short, into space to study the radiation remaining from the cataclysmic explosion called the Big Bang, which spawned the birth of our universe some 15 billion years ago. The countdown progresses smoothly.
Charge on, ordnance power on, T-minus 2 minutes, 25 seconds and counting.
To understand this space vehicle's remarkable success record of 94%, one must look back into time to understand the philosophy of the people who first created the indomitable Delta in the embryonic space age of the 1950s. America's space program in the 1950s was struggling, with failure after failure being chronicled in the day's top news stories. Then, on October 4th, 1957, Sputnik shocked the world, sending unprecedented electronic beeps to radio and television stations around the world as commentators struggled to explain the phenomenon to hundreds of millions of people. The fact that the Soviet Union was the first into space tarnished America's technological image and challenged its leadership worldwide. Public concern soared higher than ever. On January 31st of 1958, the United States orbited its first satellite, Explorer 1. Vanguard 1 followed about 2 months later. The space race had begun. On April 28, 1959, Delta was born when the newly created space agency, named NASA, signed a $24 million contract with the Douglas Aircraft Company, now the McDonnell Douglas Corporation, for 12 launch vehicles. Delta's configuration would be a 3-stage launch vehicle, the first stage utilizing the Thor missile, and the second and third stage hardware from the Vanguard rocket. Managed by NASA's Goddard Space Flight Center, Delta was to be an interim vehicle to fill a 2-year gap when more powerful vehicles would replace it. Launch vehicles like Delta are complicated, dangerous devices that require disciplined vigilance to achieve success. During an era of change, when rocket technology was in its infancy, Delta's early success record was a remarkable achievement. It is ironic that the first Delta launching on a Friday, the 13th of May in 1960, failed, presenting the Delta team with its first major challenge: pinpoint the problem. After exhaustive ground testing, the reason for the failure was identified and fixed. 3 months later, Delta scored its first success by orbiting Echo 1, a communications satellite that would be seen by more people than any other man-made object. President Eisenhower took part in the first transmission.
It is a great personal satisfaction to participate in this first experiment in communications, involving the use of the satellite balloon known as Echo.
Following Echo, Delta ran off 22 straight successes, rapidly earning the reputation of being the most versatile and reliable of American launch systems, earning the nickname Workhorse. As reliability improved over the years, Delta passed the test of time by achieving 43 successful launchings in a row, some 25 years later. Delta's success can be traced not only to superior hardware provided by its contractors, but to the people of the government industry team, especially their first leader, a crew-cut engineer named Bill Schindler. One of the youngest project managers in the history of NASA, Schindler brought to the Delta program a sound engineering background and a simple philosophy. Keep costs down, make it work, and always satisfy your spacecraft customer. This philosophy filtered down to every member of the NASA McDonnell Douglas team, bonding a lifetime partnership. Creative, honest, highly competitive, and a tireless worker, Schindler had a vision that Delta could provide flexible, dependable access to space exploration. He knew where he wanted to go and possessed the leadership ability to bring the Delta people along with him. More than 1,000 people, engineers, administrators, technicians, manufacturers, suppliers, all dedicated to the common goal. The Delta team established a standard of excellence acclaimed worldwide. During the 1960s, Yuri Gagarin, a Russian, became the first human to orbit the Earth. President John F. Kennedy was assassinated. Chubby Checker and the Twist were the rage of the nation. And American astronaut Neil Armstrong became the first human to walk on the moon. Meanwhile, with little public recognition, Delta chalked up an impressive list of difficult launchings and space firsts. One of Delta's many firsts was the United Kingdom's Ariel, the first international satellite to be launched by the United States. This 1962 launching marked the first of many international space missions, whereby the United States would be reimbursed hundreds of millions of dollars for the use of Delta, contributing substantially to the United States' balance of payments and creating thousands of new jobs in American industry. Also during 1962, AT&T's Telstar 1, the first privately built communications satellite, beamed the first live television show from France to the United States. AT&T paid the U.S. Treasury $2.6 million for the Delta Telstar launching. Possibly the most remarkable of the early Delta launchings was the world's first geosynchronous satellite, named SYNCOM-1. From its vantage point 22,300 miles above the equator, SYNCOM remained at the same point above Earth, making it possible for the first time to beam telephone calls and television programs like the 1964 Olympics from one continent to another. This unprecedented orbital task silenced those critics who said that achieving a synchronous orbit was too risky to be worthwhile. In 1965, Delta launched the first operational communications satellite, Early Bird, for the newly created Communications Satellite Corporation. As the result of Early Bird, telephone capacity across the Atlantic increased by 2/3, with costs per call dropping sharply. In a conference call with statesmen in Europe, President Lyndon B. Johnson said,
"This moment marks a milestone in the history of communications between peoples and nations. For the first time, a man-made satellite of Earth is being put into commercial service as a means of communication between continents. The occasion is as happy as it is historic."
Satellites launched by Delta fueled a revolution in communications technology, providing the world with a box seat view of history being made. When American astronaut Neil Armstrong walked on the moon's surface in 1969, 700 million people from the Earth's four corners watched his movements and heard his historical first words live via satellite.
It's one small step for man, one giant leap for mankind.
communication satellites projected all nations into the mainstream of modern world communications, new avenues to trade, education, entertainment, and the many kinds of political discourse essential to international understanding. In only 10 years, communication satellites achieved what had eluded man for 10,000 years. According to folklore, Mark Twain said, "Everybody talks about the weather, but nobody does anything about it." But Delta did something about it by launching a series of weather satellites during the 1960s named TIROS. TIROS provided the National Weather Service with man's first view of the world's cloud cover, constantly on guard for those inevitable moments when friendly weather turns to foe. Weather measuring instruments aboard these sentinels in the sky tell us when a faraway low-pressure system over our oceans may develop into a dangerous hurricane. Weather satellites created a new industry, resulting in large economic benefits to the agriculture, trucking, and shipping industries. What have better forecasts from these weather observers meant in estimated cost and human benefits? A 3 to 5 day improved weather prediction can save the agricultural industry an estimated $5 billion annually. And shipping operations in the Arctic, Great Lakes, and St. Lawrence Seaway can save about $5 million a year. Or how about the countless lives and millions of dollars in property damage saved through advance warnings of destructive hurricanes? During Delta's first decade, it also sent a series of scientific messengers named Explorer into orbits around the Earth, Moon, and Sun to study the solar wind, cosmic rays, and planet Earth's magnetic field and radiation belts. As the decade of the 60s ended, 68 of the 74 Delta launchings worked to near perfection for an astounding batting average of 92%. To accommodate spacecraft growth during the 60s, several engineering innovations made it possible for Delta to orbit spacecraft 10 times heavier. And the good news for Delta customers was that the price increase was less than the cost of inflation. During the 70s, a ceasefire was declared in Vietnam. Hank Aaron hit his 715th home run, besting Babe Ruth's record. America celebrated its 200th birthday. And Delta's list of customers looked like the telephone directory for the United Nations. Delta's schedule included a host of scientific and communications satellites designed and built by the European Space Agency, Indonesia, Japan, Italy, Germany, France, Canada, United Kingdom, and NATO. These foreign space teams were totally dependent on a highly reliable, cost-effective, on-schedule launch system. Delta met their needs. For Delta, it was an international decade, popularizing the word reimbursable, with 38 of the 76 launchings being paid for by the customer. During the decade of the 70s, the need for advanced communication satellites expanded rapidly. Delta launched 29 communication satellites for foreign countries and private companies like ComSat, RCA, and Western Union to deliver live television reports, instant telephone calls, and computer data exchanges. Nearly 200 nations and territories now depend on this communication service, which has annual revenues in the billions of dollars. In a remote Eskimo village in Canada's Yukon, children learn their ABCs via space. They watch Sesame Street and other children's programs courtesy of Canada's Anik communication satellite, launched by Delta. Another Delta-launched communication satellite named Palapa united the country of Indonesia in a way not previously possible. Palapa provides telephone and television channels to a nation of more than 160 million people living on more than 13,000 islands in Asia, covering a stretch of ocean some 3,100 miles long. This remarkable satellite system makes it possible for schools and universities, industrial plants, and oil drilling platforms at sea to keep in constant touch with the rest of the world. In 1972, Delta faced one of its most demanding tests, the launching of a pathfinding satellite named Earth Resources Technology Satellite, later renamed Landsat. Costing more than $100 million, Landsat was the most expensive satellite launched up to that time by Delta. To carry out the Landsat mission, the Delta team had to make major changes in the propulsion and guidance system. Recognizing what was at stake with the international earth sciences community, the Delta team made the necessary vehicle modifications without a previous test launching, a vivid testimonial of their faith in themselves to make the system work. And work it did, providing dramatic, detailed pictures containing new information about man's most essential needs: food, water, and energy, forcing us to become wiser and more efficient custodians of Earth's limited resources. Landsat provided scientists with a view of the eerie and unexpected beauty of our planet, enabling them to identify diseased crops, map Earth's crust for potential oil deposits, locate pollution, monitor the depletion of our forests, and inventory fresh water supplies, the most important single resource on Earth. The most productive telescope in the solar system. That's what astronomers call the IUE satellite. Launched with Delta in 1978, IUE is still operating after 12 years. Open to all scientists worldwide, some 1,600 astronomers from all 5 continents have used IUE for their investigation of the universe. By the end of the 1970s, Delta's reliability over 20 years and 150 launchings was an impressive 93%. To meet the rapidly changing demands of the satellite community, Delta once again underwent several changes, such as the straight 8 look, making its diameter the same from the bottom upward. Delta's performance for placing a satellite into synchronous transfer orbit increased to over 2,000 pounds. Quite a difference from the 146-pound Syncom of 1963 vintage. In the decade of the 80s, the United States shocked the sporting world by defeating the Russian hockey team in the Winter Olympics. President Reagan was shot and seriously wounded. Sally Ride became the first American woman to go into space. The Berlin Wall opened to unrestricted travel. And for the Delta rocket, it was business as usual. Beginning its 3rd decade, Delta's performance continued to grow to accommodate its customers of the 1980s, a host of very large communications, weather, and Landsat satellites to constantly monitor our planet's pulse, several pioneering scientific satellites, and a challenging military mission for the Defense Department. Spacecraft weight for these communications satellites tipped the scale at almost 3,000 pounds. Some of these switchboards in the sky can handle 24,000 telephone calls simultaneously, or 24 television channels, compared to 240 phone calls or only 1 television channel on Early Bird in 1965. One of several scientific missions was the 1983 launching of a satellite named IRAS, which explored the heretofore invisible infrared universe. IRAS discovered the first evidence for another planetary system like our own in its first stage of growth. Another 1983 mission involving a complex scientific mission to study cosmic X-rays for the European Space Agency severely tested Delta's ability to be launched on short notice. Because of scheduling problems with another rocket, the ExoSat satellite had to be launched over a period of only a few days, and the target date was only 4 months away. The Delta team accomplished a 2-year task during this 4-month deadline, successfully launching ExoSat precisely on time. The 180th Delta launching was one of the greatest challenges in the vehicle's distinguished history. The mission was the first for defense purposes and was given a top priority by the President of the United States. In less than 2 years, the Delta people assembled the launch vehicles, built new, unique orbital stages, and integrated the scientific payloads for this national defense space spectacular. The mission proved that a network of American defense rockets could intercept and destroy potential enemy missiles before they could strike our cities or other targets. This extraordinary program exceeded all objectives and was called the most complex command and control space mission ever conducted by the United States. What made Delta unique compared to other launch vehicle systems? It was the Delta philosophy over 3 decades, which never changed. Reliability. It had to work. Service. Meet the satellite customer's needs. Cost effectiveness. Keep the price down. Improvements systematically phased in over several years using proven systems. Careful but constant change using the benefits of state-of-the-art technology. And Delta folks at NASA, McDonnell Douglas, and the many contractors who devoted most of their careers working together, making it a way of life rather than a job. 30 years, yet the thrill of launch is still there for the Delta people as the countdown for the Delta 189 Kobe mission nears zero.
Main engine start and liftoff of Delta 189 and the Cosmic Observation Background Explorer.
Another Delta heads for space, this time with a satellite named Kobe, whose instruments will peer back to the beginning of time to investigate the fossil radiation remains and the seeds which led to today's structure of the universe. With the launching of Delta 189, the torch is being passed by NASA to the Defense Department and McDonnell Douglas for a commercial transportation system called Delta II. Delta II will carry on with the same tradition in the 90s and into the 21st century, when dreamers, creators, and builders of future generations will establish human colonies in space in man's quest to explore the final frontier. Delta changed the course of history, making it possible for many groups and nations to go into space. When historians of future generations discuss Delta's place in the annals of space rocketry, they are sure to devote several pages to this workhorse and the prominent men and women of Delta for the role they played for the benefit of all mankind.